Alright, I found a really good joke for you today. Why was the student afraid of the y-intercept? Because she thought she'd be stung by the bee. Get it? Because the y-intercept is b. I know, it's pretty good. Okay, so moving along. 3-6 is on critical points and extrema. So we're not going to do this whole section in the book. We're just going to pull out some parts of it. The first part is talking about what are critical points. So critical points are points on the graph where a tangent line drawn to the curve is either vertical or horizontal. So a tangent line is a line that touches the curve in only one spot. So if we think about this first parabola here, I can draw a tangent line here that's going to intersect the curve right there in one spot, and its slope is 0, meaning it's completely horizontal. Same thing on this parabola, have one there, slope horizontal. I have a tangent line here with a vertical slope. Slope is undefined. So there are 3 types of critical points. A maximum, where a graph is increasing to the left of C and increasing to the right of C. So C being the point where the tangent line touches the curve. Okay, so in this first example, on this side, on the left of the graph, my graph is increasing. On the right, my graph is decreasing. So this is, point C here is a maximum. A minimum, the graph is decreasing to the left, like here, and increasing to the right, making C a minimum, or a lowest value. Point of inflection is just a point where the graph changes its curvature. So notice on this third example here, I'm not a maximum or a minimum because it's kind of in the middle of the graph, but this is a point of inflection because, inflection, it's messy, sorry, because the graph is changing its curvature at C. Notice it's concave this way to the left or to the right of C, and it's concave this way to the right of C. So we have maximums, minimums, and then we have 2 types of maximums and minimums: absolute maximums and relative maximums. So an absolute maximum is the greatest value a function reaches over its domain. An absolute minimum is the lowest value a function reaches over its domain. And finally, extrema is just a general term for max and mins. So you'll often hear max and mins referred to as extremen, general term for max and mins. Okay, so this first example here, notice I have 2 minimums on this graph, one here and one here. This one, however, is the absolute lowest point, so that is the absolute maximum, or sorry, minimum. This one is going to be called a relative minimum, which we'll talk about in a minute. On this graph, the second one, notice this here is the highest point on the graph. I'm increasing on the left, decreasing on the right. This is an absolute maximum. So a relative minimum, this would be an example of a relative minimum. From here to here in this graph, that is the lowest point, but there are other lower points in the graph. So a relative minimum is the greatest value, or maximum, is the greatest, I can't spell, greatest value on an interval of the domain. Relative minimum is the lowest value on an interval of the domain. So you're taking just part of the graph and seeing is it a maximum or a minimum in that relative area. So if we look at this this cubic function to the right here, I have right here what is called a relative maximum. Notice within the confines of what I can see of this graph, that is the highest point. But I'm coming up here, that's the highest point on a tangent line, right? And we have another tangent line here. This is going to be a relative minimum. But notice here on the right, my graph is increasing, which means there's going to be greater values in my domain than the one right here. And my graph on this side is decreasing, meaning there's going to be lower values in my domain than my relative minimum. So there's going to be different absolute maxes and absolute mins, but within the domain that I can see on this graph, this is the maximum point and this is the minimum point. So those are relative maximums and minimums. So, for example, if I want to locate the extrema for the graph of y equals f of x, and I'm going to name and classify them. Remember, extrema is a general term for maximum and minimums. Notice on this graph, I am increasing to both the right and the left. That means I'm not going to have any absolute maximums because there's points outside of my range of view that are higher or low or higher than any point that I can see right now. So I'm testing for where my tangent lines are horizontal, here and here. So I have 3 critical points. One here, here, and here. This one is going to be a relative maximum. It's the highest point within the range that I can see, or within the graph that I can see. It is the highest point in the domain. But again, it's increasing on either side, so there's going to be an absolute maximum elsewhere. So this is the point. A relative maximum is at 0, 2. Then I'm going to notice these 2 points are equal in my domain, meaning there's no x values lower than them. Those are going to be the lowest points on my graph, and because they're at the same x value, I can have 2 of them. So these are going to be absolute minimums, and those are the points -2, 0, and 2, 0. So I would like you to try the next one. Oh, and I see that I drew this graph differently than it's on your paper. I believe it comes down and up like this. Go with what's on your paper. This is kind of a rough sketch. And see if you can locate the extrema for those. The rest of this we are going to complete in class tomorrow because you need your graphing calculator, and I want to be able to show you on the board. So make sure you bring your graphing calculator to class, and we will finish these notes and do some practice. Have a lovely evening.